Question number 62 wants us to find Earth's mass using the Moon's orbital period and distance from it. The way we find Earth's mass from those parameters for the Moon is to use a couple formulas for velocity. These formulas would be v is equal to 2 pi r over t, where r is the distance the Moon is from Earth and t is the Moon's orbital period. And v is equal to the square root of g times m over r. Since both of these formulas are equations for velocity, let's go ahead and equate them both so that we can solve for Earth's mass, which is the m in our equation on the left-hand side. Now we have the square root of g times m over r is equal to 2 pi r over t. Because m is underneath the square root in our equation on the left-hand side, let's go ahead and square both sides of our equation to now get g times m over r is equal to 4 times pi squared times r squared over t squared. The next thing we want to do is, in order to get mass on its own on the left-hand side of the equation, let's multiply both sides by r over g. So our mass will be equal to 4 times pi squared times r cubed over g times t squared. This is the formula that we'll use to find Earth's mass. Before we do that, though, we need to convert a couple of our known parameters. First up, there's the Moon's orbital period. The Moon takes 27.3 Earth days to circle Earth. Our value for t has to be in seconds to work in our formula. So let's go ahead and convert this 27.3 days into seconds. There are 24 hours in one day and 3,600 seconds in 1 hour. Canceling out days and hours, we end up with a period for the Moon of 2.37 times 10 to the 6 seconds. Next, there's the Moon's orbital distance from Earth, the value for r. The Moon is about 384,000 kilometers from Earth on average. That's 3.84 times 10 to the 5th kilometers. We want that value in meters, so we just multiply by 1,000 to get 3.84 times 10 to the 8 meters. Now we're ready to plug in our values and find Earth's mass. The mass of Earth, or m sub e as I'm going to call it, will be equal to 4 pi squared times 3.84 times 10 to the 8 meters cubed divided by 6.67 times 10 to the minus 11 newtons times meters squared over kilograms squared times 2.37 times 10 to the 6 seconds squared. Multiplying and dividing our way through that gives us a value of 5.97 times 10 to the 24 kilograms for Earth's mass, which, lo and behold, is the actual calculated value.